Hi, my name is Barry Bolling. I'm an application engineer with Yokogawa's Test and Measurement Department. Today I'm going to demonstrate how to make voltage, current, and power measurements on this three-phase electric motor. I'll be making the full suite of measurements including RMS voltage and current, apparent power, reactive power, active power, as well as total power, total watt hours, and total power factor. But in addition to viewing the measurements locally here at the power meter, I'm going to use a data acquisition station in order to trend my measurements over time, and also to log and monitor my measurements from a remote location. Then I will also monitor my measurements from an additional remote location using Yokogawa data logging software. Then, just to further illustrate the flexibility of the measurement system, I will demonstrate the ability to monitor the full suite of measurements using a web browser as well as from a mobile app on my phone. Okay, first let me tell you a bit about the motor. As you can see, I will have it driving a water pump. This is for the purpose of calibrating a flow meter, which is at another location. This is a Baldor motor. It is rated at 30 horsepower at 3,500 RPM. The motor has a reasonable mechanical load on it and is adjustable to a specific flow rate by using a motor drive. And because the motor requires a three-phase supply, I'm driving it with a three-phase motor drive. I have connected to the motor drive output using spade connectors and safety leads for my line-to-line voltage measurements. And for convenience, I am using 3 low-cost current clamps for my current measurements, 1 on each phase. I want to be clear that the motor drive output is a 3-phase delta source. I do not have a neutral here, simply 3 wires and a safety ground. Put another way, the power meter voltage leads are connected line to line, not line to neutral. Okay, here is the backside of the power meter. This is a Yokogawa WT1800 with 6 input elements. I have it wired for 3-phase, 3-wire, so I'm using 3 of those 6 elements. 3 input elements is simply 3 voltage inputs and 3 current inputs. This is a pretty straightforward set of connections. The WT1800 is also connected to the corporate Ethernet network, so there is an Ethernet interface that is also visible here. Because I have a network here across the first floor of the plant, I have a Yokogawa GP20 data acquisition system, which will monitor the power meter you see here. And I also have a Yokogawa data logging software suite, which will in turn monitor the GP20. Okay, so let's go around to the front panel of the WT1800 and let's get some readings. Okay, now that I've shown you the motor and the pump, the motor drive, the connections at the drive, the connections on the back of the WT1800, we're ready to look at some measurements. My line-to-line voltages are each in the neighborhood of 187 volts RMS, visible here, along with phase current and some other measurements visible here. The total power here is 360 watts. You can see the totals in the 4th column. Also, here are my delta measure computations. Line to neutral voltages of 110 volts have been calculated. Also, you can see here the phase power measurements, very important. Now that we have an idea of what our motor is doing and how these measurements look on the power meter, let's go to the data acquisition station up in the training room. We are now at the remotely located data acquisition station, the Yokogawa GP20. Here we have the same measurement data, which I have set up into 5 groups. We have group 1, which is element 1 of the WT1800. Here you can see the voltage, current, power, apparent power, reactive power, and lambda for element 1. Similarly, all of those measurements made for element 2. Again, the same measurements, but on element 3. Here's sigma A. These are totalized measurements. So I have 186 volts, 12 amps, 360 watts, about 4,000 volt amps of apparent power, and a quite low lambda of 0.09. Here's my delta computations. So I took the line-to-line measurements, and the WT1800 was able to calculate line to neutral measurements. So you'll see voltage, current, each of the phase powers here, P1, P2, P3, and the totalized power around 350 watts. The data acquisition station can simultaneously combine and display data from other sources too, not just from the WT1800. So the GP20 data acquisition station would let me show temperature of the pump water as well as gallons per minute, pressure, and that kind of thing. all on the same screen if I'd like, or in groups as I've done here. Let's go to our next platform, the data logging software, Yokogawa GA10 on a PC. Okay, now that I'm at a PC at yet another location, I can monitor and trend my measurement data using the GA10 data logging software. I have elements 1, 2, and 3, same as on the 1800 and same as what we saw on the GP20. I have the totalized measurements, so total power around 374 watts. It's moving around a little bit. And then here's the delta computations, which again, in my case, are line to neutral calculations. You can also see here that I have total power as well as phase power. So P1, P2, and P3 are in fact the individual phase powers of that motor. Now, I'm still at the PC, but this could presumably be at yet another location. I've opened a browser here and I've loaded the IP address of the GP20 in right here. So what we want to do is load the data from another remote location. I click on Overview and it shows me the same measurements that I've shown you before, element 1, 2, and 3, the totalized sigma A, and then the line to neutral computations called delta A here. This page is highly configurable, but I'm going to keep it simple and just show you there's element 1, you got your volts and current RMS, volt amps, power, reactive power, and lambda, same for element 2, as well as element 3. Here's your totalized, there's your total power, 375 watts, and your delta computations. Here's your total power, 363 watts, it says here. The most important thing I can show you on this page is delta P1. In other words, this is phase power. The power on phase 1, phase 2, and phase 3. So that's it. This is web access to your data from anywhere on your network. As I mentioned earlier, we also do have a mobile app for monitoring the measurements remotely as well. I have previously installed the real-time data module, or the mobile web app, onto the GP20. Again, this is a real-time data module that runs on the GP20, essentially as a web server that's customized for mobile devices. So all I've got to do here on my phone now is to bring up the GP20 in the phone's web browser, in this case Safari. And there are all the measurements that I want to watch. Here's an overview. You can see element 1, 2, and 3, sigma. I'm going to press delta A here. In addition to just watching my measurements, I can monitor and set alarms, perform start-stop on logging, and of course data monitoring, all in real time. To review what we just demonstrated, today you saw the WT1800 power meter on site back in the pump room. We looked at the meter and the motor drive and made some measurements back there. Next, we viewed the measurements here in the training room on the GP20 data acquisition station. Then we viewed the same measurements on the data logging software. Then we loaded the same measurements on the PC's web browser. Finally, we loaded the measurements on the mobile web app. So in this example, I was able to do this from the iPhone, but Android and other mobile devices are also supported. As you can see, it is very convenient and offers a wide variety of ways to monitor your data measurements. Thank you for watching. For more information, please visit tmi.yokogawa.com.